In this video, we'll look at more ways and better ways to solve systems of linear equations in MATLAB. Let's do a quick review. Oops. Let's do a quick review. Another example. Suppose we had this system of equations we wanted to solve. What we did last time was create a coefficient matrix, which was 1, 2, 1, and -1. And we created a results matrix, which is the right-hand sides of the equation. This is going to be a vector column, column vector, so use a semicolon there. 5, -1, and to solve, we just need to do inverse of A times B. This is another way to say, by the way, inverse of A is the same as A to the -1 power. Okay, and now when I don't need to see that, and now when I run this, I will get a solution, 1 and 2. So this is telling me if I plug in x equals 1 and y equals 2, that will solve the system of equations. And I can check that one by hand pretty easily. But there are better ways. So that's what we're going to do today. MATLAB has a built-in more efficient command called backslash, also known as matrix left division. We said last time that we're kind of dividing, and multiplying by the inverse is kind of like dividing, but there's a more efficient way to do it in MATLAB. Instead of calculating the inverse separately, we can just do this special command, and MATLAB will do the work a little bit better for us. So this doesn't come up very often. You won't see much of a difference when you're only working with 2 or 3 variables, but you might be solving a system of equations with 100 variables, or 1,000. That's a lot, but 100 is not that uncommon. So using a more efficient way is going to be a lot more important in those cases. So let's take a look. I've already got the A and B here, so I'll just say x equals A slash B. Notice it's a backslash, we're going backwards. So if I run this section, I get the same thing, x equals 1, 2. So I got the same thing both ways. Same answer, more efficient, and that can make a difference. So if you ever are doing one of these problems and you get like 0.0001 instead of 0, that's a sign that we're just rounding off a little bit wrong somewhere, and MATLAB would be better off using backslash, matrix left division instead. So let's do another example. Let's solve a system of equations with 3 variables. I just pasted this in. If you need to pause, that's fine. But what we really need in MATLAB is the coefficient matrix. I'm going to call that A again. Like I said, that's tradition. So I'm going to use a square bracket. I'm going to read the coefficients across the top, middle, and bottom. By the way, have any of you had to solve these by hand? Did you ever do 3-dimensional or 3-variable systems of equations in algebra? Maybe you did, but it's a lot nicer to have MATLAB do it in one single swoop, I will tell you that. So I don't need to see that. B, which is the right-hand side, it has to be a column vector. 2, semicolon, 3, semicolon, -6. Don't need to see that, although we could look at them in matrix form real quick and see that, yeah, we've got A, 3 by 3, B, which is a 3 rows, 1 column, and now we're going to solve using matrix left division. X equals A inverse slash B. Okay, backward slash is for matrix left division. And run section, we get our answer. Boom! We have an x, a y, and a z, and they're always going to be in that order from left to right, because that's how matrix multiplication works, right? This is associated with the first one, the second one, and the third one. So we could check that by plugging in these values and seeing that we do in fact get 2, 3, and -6. We can also use MATLAB to check it and just say what's A times x. Notice we're using regular times here, not a dot star, but just the regular star, because we're doing matrix multiplication, not element by element multiplication. And I should mention that it's really common to get something that's really close to B, but not quite. So let's check this, allowing for a tiny bit of drift. And here's how I want to check it. I'll use an if statement. I'll say if the absolute value of a times x minus b is less than a really small number, then we're fine. It might not be exactly 0, right? It should be. A times x is supposed to be exactly equal to b, but this is a computer we're talking about, and depending on how complicated and messy your problem is, you might be off by a tiny little bit. So I'm going to say if it's less than 1 times e to the 10th. Oh, this is scientific notation. 1 times 10 to the 10th, right? So I'm going to say if that's, oops, I don't want 10 to the 10th. I want 10 to the negative 10th. I want a really small number, not a really big number. Then I'll say this is fine. And otherwise, in this case, error is bigger than I want, then display something is wrong. Okay, so this is one way to give yourself just that little bit of wiggle room. Let's run this. I think ours is going to be exactly, yeah, this is fine. It might round to 0, but MATLAB is keeping so many decimal places. It's keeping track of a lot, so that's why sometimes you get something that's not exactly 0 but really close. And I just want you to know that really close to 0 means it's good enough for us. All right, that's all for now. I'll see you in our next video.